Hey y'all, I'm going to finish up this example story and draw the displacement versus time graph or the position versus time graph. They're the same thing, however you want to label it. Down here is what I did last time with the velocity versus time graph as well as the accelerations. So those two parts are done. We just need to do the position versus time graph. So I'm going to start with drawing my axes. And look, something like that. I'm only drawing the top part because all of my displacements, all of my positions are positive. If you have any negative ones, you would need to just extend your y-axis down like that. This one is going to be time, and it's in minutes. My y-axis, you can write it as displacement or position. I'm going to write it as displacement. And that's measured in meters. There we go. Okay, so use your velocity time graph to tell you everything about your displacement time graph. I'm going to start with this first section. My velocity is constant at 1, which means my slope for my displacement time graph is going to be 1. You can also think of it as the area method. Remember, we could fill that in, and the height would be 1 for this first part. The width would be 30. So 1 times 30 is 30. So my displacement is 30 for this first piece. It goes to 30 minutes. So there's my 30. And then I know my displacement, I'm going to end up at 30. So I can label that. And then right here is where I'm going to end up at. There's my first piece. I'm going to separate each of my sections by a small yellow line. This is for you. You don't have to do this on your graph. If you want to, you can. But this is so that it's easy for you to see which section goes with which other section. It's a lot easier to see the sections on the velocity time graph than the displacement time graph. All right, let's do the second part. The second part goes to 40 minutes. Okay, so now we have a slope for our velocity. That means we're starting at 1, ending up at 0. That means our displacement time graph has to be curved. Our velocity is changing that entire time. So, there we go. That's where my section is going to end. I'm going to start with the same slope I had over here. And it's just going to slowly become flat. Something like that. Okay. So that's for the second part. It becomes flat because we end up at a velocity of 0 here at 40. All right, for the third part, this part right here, we have a velocity of 0 the entire time all the way to 120 minutes. Let me put that on my graph, 120. I'm going to section it off again. There we go. Since my velocity is 0, that means I'm not moving at all, or the ladybug isn't moving at all. So it's just going to be straight across line like that. Remember, your velocity should equal your slope down here. So if I was finding my slope, this, since it's straight across, my slope would be 0, which matches my velocity. And this one, it's got a rise of 30, and a run of 30. So my slope is 1, which also matches my velocity. Okay, so I'm good so far. This last section it jumps down all the way to -1 meters per minute. So what we're going to do for the displacement is we're not going to have any jumps like this. Your displacement shouldn't have any jumps vertically like that. It should always be kind of a smooth graph. We're just going to have a little nook here. If I check my story, it says walked back to her home, and I said that her home was my reference point, was my 0. So she went from where she's at. It's a constant velocity. So it's going to be a straight line all the way back. So my jump here for my velocity time graph is going to end up looking as a little corner, as a little nook on my displacement time graph. And that's at 160 minutes. Okay, almost done. Before I move on, I'm just going to check my slope. One thing you'll notice is that I didn't actually say how far the ladybug went here. So I just made the assumption, I also didn't say up here. So I just made the assumption that that was 50. If you need to make up some numbers along the way, that's okay, as long as they match what's happening in your story. So if I have a slope, the rise or fall in this case would be -50. Whoop, okay. -50. My time is 160 minus 120, which gives me 40. So my slope is a -1.25 meters per minute. Okay, and the last piece. Walked from her home and sped up away. My velocity is increasing. I've got a slope here. So it's going to be curved. I start at 0, and I'm going to end up at some velocity. It doesn't need to be exact. Since I start at 0, that means it's going to start off flat here, and then it's going to increase. My velocity is increasing, so my slope is increasing. Just like that. That's going to be 180. My divisions on my x-axis aren't even, but that's okay. We're just kind of doing a sketch. Okay, so I've got 1, 2, 3, 4, 5. I've got all 5 of my sections, so I'm done. Just make sure that when you're drawing this, it's one nice, smooth graph. No jumps like there are in the velocity time graph. Also, just a short reminder, when you start at 0, you start at 0 meters per second or whatever your units are in, your graph will start off flat and will either go up or go down depending on which direction you're going. Okay, so all of mine were away from the house. So I started flat and went up for this, started flat and went up for this last section up here. If I was at the park and she started at 0 and started speeding up towards home, it would be curved downwards like that. If instead you are ending at 0, so basically starting at 0 would be speeding up, ending at 0, starting at 0 is speeding up, ending at 0 is slowing down. So you're going to start with whatever slope you had before. So you're going to have some kind of slope. It could look like what I have on my graph. And then the end is going to be flat. Or It could be something like that. Either way, it ends flat. Whichever side it starts at 0 or ends at 0, that part is going to be the flat side.